Hello everyone, I am Chandana and today I'm going to be explaining about compilation and execution flow in Java. We're going to be understanding what exactly is compilation and execution, what goes into the process and how our output actually comes, what's the behind the scenes, what's the working behind the Java program. So we're going to be having fun today as we're going to understand what's inside the brain of Java. Okay, so what happens when you run a Java program? I've given a flowchart where we actually write a program. Then it is compiled by the Java C compiler. Now this compiler will generate the bytecodes. The bytecodes are then executed by the JVM. Finally, it shows us the output on our computer. In this case, it has given us hello world. So 1, you write the code. 2, compile. 3, bytecode. 4, JVM. 5, output. This is it. It's just a 5-step process. Now, let's get started. First things first, we have to write the code. Without the code, nothing's going to work. So Java program is a human readable text file. We are writing it so it's human readable and we are writing it with a .java extension. The thing about .java is that the file name must match exactly with the public class name that you declare in that program. For example, hello.java contains public class hello. Here hello and hello both are same. Class name is same as the file name or else it's going to give an error. So here I've written file format is saved as .java. Example hello.java. It's human readable, is written plain text using the Java syntax, entry point, and every app needs a main method. Without the main method, it's not going to run, it's going to give the error. So there are many places at where you would get the error. It is when you do not, when you forget some semicolons and if you do not give in the curly braces or the main method. That's one such errors. We have to try to avoid them or minimize these errors. Now, compilation. This is our topic, right? Compilation. We've heard about compilation. We've heard about compiling videos, but what is compilation in Java? And most importantly, why do we need a compiler? So the thing is, we are writing in human readable form. As I've told before, the computer won't understand a single thing. If the computer won't understand, how are we supposed to get the output? So we came up with a plan to change it to actually an intermediate code called it's also the machine code binary. Now this is done by the Java C compiler. So the Java C compiler is simple. It acts as a translator between the program that we wrote and our output, which the computer, which the machine will understand. It bridges the gap by translating that high level code into an intermediate form called bytecode. Now, this bytecode is really fun because just because of this single thing called bytecode, Java is it can run anywhere. It is platform independent. So here again we've written hello.class file is generated. That is the Java C compiler. Java C, that is Java compiler. Here we have given the statement high level program. The compiler compiles it into 1071, that's the binary code. Then it finally executes to give the output. Now the bytecode, the secret sauce. What is bytecode? I've told about bytecode. I didn't really mention what exactly is a bytecode. So after compilation, your .java file is now converted into a .class file that contains the bytecode. It's an intermediate low level instruction set. It's not specific to any CPU or any system. It's not like it will run in my computer and it won't run in your computer. It will also run in every single computer in the world. So that is Java. Write once and run anywhere. That's a superpower. Now, the .class file output of the compiler intermediate. That means it's neither the source code. Source code is the code that we've written. It's not that, and it's not the machine code. It's just the bytecode. It's the bridge. and it runs on any OS with a JVM. What is a JVM? JVM is Java Virtual Machine. Next, here, the last thing that I told about is JVM. Now, what does the JVM do? The JVM reads. Now, okay, so right now our file is in a dot class bytecode. Oh, and the computer still doesn't understand it, okay? It's not human readable anymore, but it's still not the language. It's not your mother tongue for the computer, from the computer point of view. So it converts it into the native machine code that your specific hardware and OS can actually execute. So the thing about JVM is that because it converts into the language that your OS can execute, that's the reason it's also platform independent. It can run anywhere, wherein the program can actually execute because you're writing in this native language. Class loader. JVM has a class loader. It loads the dot class file into the memory. Now, interpreter. So it's written in bytecode, right? It needs to be transformed into the machine code. So the interpreter executes the bytecode instruction line by line. Now we have the JIT compiler. What is JIT? JIT is the just-in-time compiler. Now this compiler optimizes code parts to native machine code for speed. So finally, with the help of all these processes, we get the native machine code. Now, what's the output? We've done all the work. We, in the sense, the computer, the machine, the CPU has done all that work, and finally the program runs. In this case, I've given a simple hello world program. Hello world. So once the JVM processes the bytecode, your program executes and this produces the output. This is what we want. We just need the output. For a simple hello.java, the JVM makes a main method and runs each statement in order. The result is printed and your program is alive. What's the result here? Hello world. So the only thing that we actually wrote is hello world. The rest of the part behind the scenes is done by the machine. So see it in code. Here's what a complete hello world program looks like in the terminal. Hello world. So actually I would be showing it in a bit later. I'll be showing it how to actually code. It's just a simple code that I've chosen. It's the same hello world code. Now, what did we just learn? I'm just saying it. Java. It translates, the compiler translates it into the bytecode. The JVM, the computer still doesn't understand, so the JVM comes into picture and it turns the bytecode into the machine understandable language, and finally you get the output. Notice how the JVM acts as a universal bridge, making bytecode run on an operative system. Now the key takeaways. Java me. So basically we have two-phase process. Java uses compilation, Java C, compiler, then execution. So that is how we get the output. And bytecode is actually the portability. Bytecode is the suitcase that we carry along so it can run anywhere. So the dot class file is platform independent. The same bytecode runs on Windows, Mac OS or Linux, anything. Now, JVM is the engine. The JVM converts the bytecode to native machine code at runtime using an interpreter and a just-in-time compiler. Thank you. Okay, I did say thank you, but that's just the thank you for our slide. I'm going to go into the actual coding part. I'll be showing what exactly we need to do. So, I'm going to be going here and I'm choosing a new file and I want a Java file. So new Java file. Okay. So automatically main will come, but I want it to be hello world. And this is actually a camel case. That means we should not give any gap. Now I'm writing public static void main. Open bracket, capital, string of Rx. Open bracket, curly braces actually, open curly braces. System Now we need the output, right? We need to write something. System dot out dot println open bracket hello world. Now this is what is going to be displayed. The user is just going to see this, and do not forget the semicolon. So that's done. Now I'm going to be saving this file. Save as. I want it to be hello world. So if I do not save it as hello world, it's not going to run. So hello world.java. I've already done this, so it's going to ask me if I want to replace it. Yes. Okay. So that's done. Then I will give it run. I'm doing this in VS Code. Run with a debugging can also debug. And here you got the output. Here, hello world. It has given the output hello world. This is actually where I'm storing it. I'll just show it. Hello world. And that's how you get the output. As simple as that. Now this is simple. That's it. You don't need to do anything else. There's nothing more to Java. Java is simple. This is it. That's only thing that you're actually going to be using the compiler and execution. I hope you understood this concept, and thank you.